Good evening, everyone. Thank you for joining us. Good evening, everyone. Thank you for joining us tonight. I am pleased to introduce to you Tim, G1HBC, glamorously assisted by Paul G.
He's my glamorous assistant.
I met these guys over the Verulam meetings. It was at some point last year, wasn't it, that Tim did a talk about his experience building and using Slim Jim antennas. And I thought it was an absolutely fantastic talk, and then we were thinking about the club programme for this year, and I wanted to invite Tim to come and deliver the same for us, because I thought it was a fascinating topic.
I hope it still is.
I'm sure it will be, and as you can see, there's several antennas already out, so I remember when you did it sort of the first time around, was talking about a lot about your experience building them and how you really refine the process. So yeah, we're also being recorded tonight, thanks to Alex. Thank you, Alex, for getting all that set up. So yeah, I'm not going to talk too much longer, and I'll let you guys crack on with it. Yeah, do you want a chair? There's a couple here. We're going to grab them.
Making me nervous, Dan.
Do you want to sit this side? Or? Yeah, here we go.
Ready?
Take it away.
Okay.
Roll credits.
Yeah, thank you for inviting me. As Matt said, we gave this presentation to Verulam. I've made a couple of changes to it because you revised it. So my first question is, why are we radio hands or radio amateurs for those who don't like the term hands?
He's got you cops already, right?
I heard him. Yeah. So why are we radio hands? What's our purpose?
Communication, experiment.
Hide from the wife.
Experiment. This is from Ofcom, and apparently that's what is it Gemini?
Yeah.
Gemini thinks radio hand looks like. So it's a bit of like AI graphics there. But in my old licence, which is now 41 years old, I've still got the original piece of paper. It does actually say for experimentation. Is one of the prime reasons. I don't think it actually mentions communication. We use communication to
Mine certainly said communication.
does it? Yeah. There's certainly there's a phrasing which I think may have slipped out of the new licence about experimentation. So on the basis that we experiment, what do we experiment with? It's a very very wide hobby, as we know. And Paul and I came back into it 2 or 3 years ago, having been out of it for about 30 years. And we went, whoa, haven't things changed? You know, we're talking about Shari nodes and All-Star and Echolink and things like that. So, but experimentation can be electronics, it can be hardware, it can be all sorts of things. In this case, I was thinking about it, back in the day, in the mid-80s, you didn't have the internet, you didn't have online shopping. So if you wanted an aerial, where did you go and buy one? You couldn't sort of just browse and think, well, that one looks nice, that one looks nice, that one's cheaper from there, that one's more expensive from there. So, and back in those days, I was on 2 metres only. So what is the Slim Jim? We do have the answer to how it became named as Slim Jim, we'll bring that up later. But what is a Slim Jim? It was traditionally used and it was designed by a guy called Fred Judd to G1HBC. It was developed at the J-pole. The J-pole, I don't know how long it had been around before that, but I imagine for quite some time. And he made a better aerial. Although the purists would say these aerials shouldn't work. Who was it that Verulam got under it, wasn't it?
Oh, David.
Yeah. Apparently, this basically shouldn't really work, but they do work. But if you think of it basically as a folded dipole, it is quite high gain. It has a low angle of radiation. Importantly, it doesn't need any sort of ground plane. So no bits of light hanging there or going through or counterpoises or anything like that. can be very cheap to make. You can make it a little bit more expensive, but I'll talk about that later. It's easy to make and it's very portable. So if you want to take it on a camping trip or anything like that. The basic difference between the Slim Jim and the J-pole is the Slim Jim has got a higher angular gain. I'll just go to the next slide. Allegedly, and it depends on which bit of the internet you read and which bit of text you read, the Slim Jim over the J-pole has got 6 dBi gain. And the J-pole is a good area on its own. The bandwidth is better with the Slim Jim, and you're down from about 20 degrees with the J-pole to 7 degrees with the Slim Jim. So you will go further with it. You've got better angle of radiation, and you've got a high dB gain. So I don't know about this is weak stations, lower noise floor. Anyone got any comments about that? Because traditionally uses on 2 meters FM, it tends to be quite quiet. Anyway, this is not 40 meters, anything like that. But apparently, it's better for low noise. I mentioned that Slim Jim is traditionally was used mainly for 2 meters. So that's a 2 meter Slim Jim. This one's 41 years old. Doesn't work now. But you see it's quite compact and lightweight. So that's a 2 meter one. You don't have to limit yourself to 2 meters with the Slim Jim. So you can get the benefits of the no ground plane, the low angular radiation, and the low noise ratio on any band. Anyone heard of fly-to-wear?
Yeah.
Anyone not heard of fly-to-wear? It's, how would you describe it, Paul? I'll let you...
Okay, it receives broadcasts from airplanes about their position, velocity, altitude, etc. And a lot of people, like Tim and myself, we feed it back to flight-aware, and they use it to supplement basically the tracking of aircraft. So even in densely populated places like, southeast of England, they are used quite a lot for additional information about aircraft. And you can see on this shot here, it's picking up aircraft all the way to the Netherlands and up towards Coventry and Manchester, Birmingham quite often. And that's from your station, isn't it?
That's from my station, yeah. On this slide here, I was picking up 94 aircraft. This is live, using the slow internet.
You still have 60 aircraft.
Yeah. So less aircraft flying around this. But this is live, but this is actually using the Slim Jim, which is made for 1.09 gigahertz. It's about that long. And I didn't have a VNA to tune it.
So how long did you spend tuning it?
I didn't, I guessed. And I'm leaving it well alone because it's working really, really well. Yeah. But I'm using this as an example of the Slim Jim, because it's got a low angular radiation and low noise. It's picking up aircraft right out into the Netherlands, up into the Midlands, north of Birmingham, and out across just the other side of Gloucester into South Wales sometimes, where you don't get many aircraft flying over that. So that's just an indication. Now, Paul's got the same setup as me, except these two slides were taken at roughly the same time, within minutes of each other. And your setup is still using a Raspberry Pi on the receive end, but he's got a very expensive commercial area. And you were picking up 54. And that's a commercially made sort of 80, 90 pounds commercial aerial designed for the job. So just an example of the differences a good Slim Jim can make. I'd probably frighten myself if I put a VLA on it and saw what it was really doing. But
Assuming they're both outside and relatively high up then.
yeah,
That you're getting those results in the first place.
yeah. Actually, funnily enough, it's my highest aerial. But yeah, it's just as demonstration of what a very simple basic aerial can do. It's made, and we will go into the construction of these. It's made in the same way this one. This is the 77th one. Bit of white plastic. That is a bit of tent pole, fiberglass tent pole. Drill a hole at each end to get your dimensions there, and this is just some 2.5mm electrical wiring with the insulation stripped off and turned into an aerial. But the aerial we're using for 1.09 gigahertz is made in exactly the same way and put into a plastic pipe. We'll talk a little bit more about the construction of those in a minute. So that kind of proves a point about the aerial. So if you want to do 2 meters and just have a handheld and put a better aerial on it, it'll work very well. So there is a calculator, a nice online calculator, where you can actually put the dimensions in. And if I do on my mouse, here we go. It's m0ukd.com. What you can do here is you can put in the frequency you want. He talks about velocity factor, that's to do with the coax. So if we just do a calculate on Slim Jim for 145, and it gives you dimensions. And it tells you what your A, B, C, D dimensions are. So for any frequency you want, this will then give you those dimensions. What he does mention, but if you're going to build one, is F, not critical. So that's the spacing there and there. What I would say, yes, it isn't critical, but it will affect the tuning point down here. It gives you a dimension for the tuning point D. If we go back up. So D here would be 5 centimetres, 2 inches. That will actually vary. I think also depending on the thickness of what you're using and the spacing, but the spacing isn't that critical, so you can make it quite thin and put it into a piece of plastic.
And with the measurements from that calculator, what sort of bandwidth would you expect? Would that design, if you made it exactly with exactly the measurements he said, would that cover the whole of the 2 metre band? Or would
Yeah, this covered 144 to 148, but I did have a modified, you can cut that out of the video. Had a modified FT290, still got that FT290.
It's 40 years ago, I'm sure.
40 years ago, yeah. There was a cutter leg of a capacitor modification.
Right.
I didn't really ever transmit up there, but yeah, absolutely not, never, no.
Yeah.
But you could. It's amazingly wide bandwidth, which is why if you go back to the beginning of the stuff, that's one of the differences between a J-pole and a Slim Jim. You've got a much bigger bandwidth with these, amazingly big. We did actually do a calculation. You can put in here something really stupid. So, So we could do a 20 metre one. It would be very big. What's the A? 21 metres. It would be 21 metres high. It would be a very big area, but it would be interesting to build one.
One or two people
On the
here.
basis of experimentation.
One or two people here who are quite into top hand, so.
You need a very high pole to put it up.
Yeah.
Although in theory, of course, you could go horizontal. So be interesting actually, Matt, for you to model that.
Okay.
The Slim Jim vertical. What happens when you actually tip it horizontal? You might be.
It probably behave very much like a dipole.
Yeah, I think so. But it'd be interesting to actually see what the modelling is on there. But yeah, that's the point. You can make it any frequency you like.
Top hand dipole,
So I could do with a 15 metre one. That's another story. Right. So construction. All sorts of different ways of doing it. This is the traditional way. This came out of this book here. I bought the original of this book 40 years ago, and about 2 months ago I lost it. But I managed to find the PDF online today and managed to reprint it. I'm going to send the PDF to Matt. If anyone's interested in the PDF of this book. This was a practical wireless day. This is a practical wireless book about propagation and building all sorts of different areas. It's actually quite interesting, full stop. So I'll send that to Matt if you want. Matt can distribute it. The actual. I think it's all royalty free these days, being the age it is. Oh, is it? That's an interesting slide.
I'll check that on the WhatsApp group. Maybe that'll be a nice, easy way of getting it out.
Yeah. Can't find out. But the design for this is actually in here with all the dimensions. So that's quite handy. The downside of this type of construction is really good. And this area worked really well. Right, it's so old now. Probably the joint nuts and bolted joints probably aren't very good now with corrosion. One thing you've got to do with it, this is the insulator side, here's your coax. The screen must always go to this side, where you've got the short stub for the insulator. If you do it the other way, it won't work. So that your core of your coax goes to the folded dipole side, and you can probably see there's one or two holes.
So you're saying it's naturally unbalanced then?
Yeah. But you do have to play with that. If I was going to build something like, and the downside of this, and you can see the construction here, is actually making that having a box around that and making it waterproof. It is possible. I did have a plastic box around that, and it was all sealed up at one time. If I was going to do it today, my other hobby is a model engineer, so I've got lathes and milling machines. I would make a couple of collars with rub screws, so I could actually just slide them up and down to get the tuning point. This was less than 1.1 it was nothing. It worked beautifully. Put 100 watts into it, it went really well. Do you want to pass that around? If I was going to make that today, I'll probably use 15mm copper pipe and soldered joints on it. It wouldn't look very pretty, it might upset your neighbours, but it would work very well. Now, if you don't want to upset the neighbours, white plastic pipe. Any reason we wouldn't use black plastic pipe?
Yeah, too much carbon.
Yeah. Top. Yeah. Not always, but a lot of the black plastic's got carbon in it. So that doesn't do air exhaust good.
We found that.
Oh, we did that find out the hard way. Yeah. So I think this is 21 mil overflow waste pipe. So quite cheap. Rubber bung in the top and a bit of a self-amalgamating tape. And a bit of wooden dowel. And again, some 2.5 mil electrical wiring. And again, you'll see there, when you look at that, it took me a couple of times to get the feed point right. What you'll find when we go back to that calculator, it'll give you a dimension. I would treat that as a starting point, and you sort of go up and...
Does the chimney alter when you put it in the pipe?
If it's black, yes.
Yes, it can, but quite minor. Yeah, you're going to go from 1.1 to 1.12 or 3. But it can make a difference, and that's a 77s version, and that's another 2 metre version. You can using ladder line. You can use 300 ohm ladder line or 450 ohm ladder line. That's quite handy because I've just got a cable tie in the top, so you can hang it up somewhere. Particularly if you were going to do a 2 metre parks on the air or something like that, would be quite handy. That rolls up in your rucksack.
That is really nice, actually. I'll sit up. Might build one of those for my next holiday.
Well, yeah, outside the tent would be your bottle of beer. This one, I think I used, this is slightly thinner tubing. I can't remember what size this is. This actually fits. The reason I've got a cutout there is I can bring the coax out there and that will actually fit into a 22 mil copper water pipe. Well, yeah, but you can use the water pipe, as your mast. That goes in there. It's completely water. Water can get in there. It doesn't matter. It'll go down. It's got more bits.
If you want to check if your plastic is conductive or not, cut a bit off and stick it in the microwave oven and see if it gets hot.
When the wife's not looking.
Well,
That's a good point, actually.
Stick it in the microwave, and if it gets hot and melts, it's no good for radio.
Okay.
Well done.
Very good.
Can I quote you on that when she had it done?
Yeah, all the best fights start with, well, a chap at the radio club told me.
Well, yeah.
I've been around for years, that idea.
Well, one of my other hobbies is model engineering, and I did get caught out one day tempering some springs on the top of the cooker. I had these were small leaf springs. I'd hardened them, but I needed to temper them. I had a piece of 6-inch square, 1/4-inch thick steel plate, put it on the top of the cooker just so it got a nice even temperature. And when it went blue, then she came in just as I was putting them in the water to temper them. So I did get shouted at. Well, actually, it's quite short and sweet. We've gone through that quite quickly. Any questions?
How do you tune? How do you get good tune? Because that seems like the magic of it.
Yeah, because he can't do it.
So what I've noticed, or what I think I've noticed, I can see from that one, is
Yeah, there's been a couple of attempts.
they're always, yes, first of all, there's a few attempts. Second of all, with the connection for the shield and the core of the kayaks is always the same height up. So is that a critical factor?
Yes.
Or do they need to be, okay.
Yeah.
So if you look, if you look at this one,
Yeah.
there's been a couple of attempts, and I think this is one I made.
No, that's what I
That's
made.
one you made.
Well, I made. No, I actually think it might be one I modified that you made it.
Yeah. So the initial one would be the, said in the
Yeah.
diagram. But then Tim, with his engineering eye, goes, actually, no, I need to move it up here a little bit, and it just works for him. So we just test it with SW1.
Okay, so you just have a VNA on
Yeah.
it and then connect it a few times and see where you end
Well,
up.
I didn't have a VNA at the time, so mine's purely done with an SWR.
Okay.
VNA is better if you've got one.
And then when you're choosing it, is it a case of you move it half a centimetre up and you go from 1.3 to 1.1, or are you going from 10 to 1 to 1.1 to 1? Is it what I'm getting at? Is it quite sharp when you're choosing
It is quite sharp. It can be quite sharp. Yeah.
Yeah.
This is the point of this. This one wouldn't be very sharp.
Why is that?
And I think it's because of the spacing and the thickness of the material. I
Right.
found this one was quite easy to tune back in the day, but when you're using something thinner and smaller, but that's because you want to create a white stick type
Yeah.
aerial because it's less offensive to the neighbours, you'll find that width dimension and the thickness of the material you're using does make it harder to get it right, but you can get it right. A little bit, I use my engineer's eye, go, no, I should be there, and I'm probably somewhere close.
So does that imply that that one's got more bandwidth? Wider?
This would have more bandwidth than that, but that will still be very good. That will cover the whole 2 metre band, yeah, and that would cover most of the 70, certainly the FM side, voice side, yeah.
So have you made any others for any solutions for any other interesting bands? So you mentioned the 1090, 2 metre 70 cents.
I haven't. I'm seriously tempted to try HF. But it's also why I'd be interested to know will it work that way as well, particularly for HF.
Yeah.
Because for HF it's going to be very long. It's going to be easier to do that than have 21 metres high aerial vertical. You know, 3 times that size height of your house, isn't it?
You're probably better off on 10 metres if you're going to do that.
Yeah. I think it's certainly work on 10 metres.
Yeah.
Yeah.
And we usually play with.
I personally want to try 15 metres because my aerial doesn't work on 15 metres, so I've got a gap in my.
Oh, okay.
Another reason it's modern done.
All right.
But,
And you were saying about doing saying about using collars with grub screws on for.
yeah, I have made some other ones which I haven't got tonight, where I've got some copper tubing, thin copper tubing. If you use car brake lining tubing,
That's why it's not the white smoker.
exactly, yeah. Just make sure she's insured first. Then I made up some brass collars.
Yeah.
The coax screwed into the brass collars and it had rub screws in the collars, so I could just very easily move the collars up and down.
And could you scale that? Would that scale down to something more like the white
I could do, yeah.
Interesting. Okay.
I mean, we use crocodile clips as well to try and get near enough to the point.
Right. Okay. So you're not having to resolder it.
Not to resolder it. No.
And when you get to that point, I mean, if you were to solder, 2 millimetres away from where the crocodile clip was, is that going to cause a major issue, or will it still be pretty close?
That'd be pretty close.
It'd be pretty close, but it does change a little bit once you change from crocodile clip to solder.
Right.
But it gives you a very good starting.
So it's a good way of wasting the evening, is what you're saying.
Wonderful way of wasting an evening, yeah. But this doesn't work anymore, so I'd imagine I've got corrosion. But this was actually designed was originally in this book, using this, and back in the day I had some aluminium piping and I just crushed it into two big 2BA screws in the corner, and it worked beautifully. It probably worked beautifully for about 20 years in all elements. So
Screws are the brass, steel.
they are brass. So there could be some electrolytic action between the brass and the aluminium. Any chemists in the room?
No.
Well, energy system.
Similar metals, yeah. But back in the day, you know, 40 years ago, that's what I had in my back pocket.
You
as
probably
well.
didn't build it thinking, in 40 years ago to justify why I use brass instead of
Exactly, yeah.
something else.
Yeah.
I just dip them into some bitumen to make them watertight.
Yeah.
The normal loose sealant stuff is brilliant for making the stuff watertight.
Yeah. Well, in hindsight, yeah.
Just dip them in there and they won't corrode.
Right.
So
It
put
did,
the
it did
solder
work.
off
It did
the-
work. It still sort of tunes up, but you wouldn't want to use it. You might blow your radio up. You know.
And did you say you had a box on that one as well?
Yeah, I did have a round junction, electrical junction box around there, and then lots of sealant around it. And that again, that worked fine for quite a long time.
Till the ceiling gives up.
Well, yeah, basically, it doesn't last forever, does it?
No.
So, I made one last question.
No, keep that. No, it's good.
So how did you mount that to a pole? Because it's all radiating on, right? So
Yeah.
Oh, that was on the back. That was on the bottom. Oh, I see.
Yeah,
Right,
so-
next to the box.
Yeah, so I didn't have a bracket like that. I think I connected it straight. But you have something like a wooden pole,
Right.
so it's not not going to affect the area at all. So these days we might use fiberglass pole or something like that.
Okay.
It doesn't have to be very long. So, or these days you don't need that bit, because you might have a fiberglass pole there and just screw it straight onto the, or clamp it straight onto the fiberglass pole.
And that M0 UKV calculator, will that work for building the ladder line version as well?
Yes.
You need to change the spacing.
Yes.
Okay, brilliant.
What I have seen some people do, where's the ladder? Who's got the ladder? What I have seen some people do with this, the tuning, at this end, they've put the connector block,
Oh, like a chop block.
chop block
Yeah.
there, and actually just change the length of the tail. So although you're changing the whole length of the area by doing that, it makes it very easy to you don't muck about with that.
Yeah.
You don't have to cut. You don't have to chop into the insulation here and try and solder it. If you feel carefully under there again, there's been a cut 2 or 3 attempts to get that right. If they just make the tail shorter or longer, it makes it very easy. Makes it much easier to tune.
Make it a lot easier to keep the
Yeah.
lengths,
And
the offsets uniform as well, wouldn't it? Because it's all going. Yeah. Okay.
then, as long as you've taped it up afterwards, once you've got it working, it's fine.
Right.
Another thing I didn't mention, of course, and I'm open to debate about this, is with 70 centimetres, 2 metres, I've never bothered with a choke. Any sort of RF choke. HF, yes. We were talking about that before the meeting, weren't we? But an easy way to make an RF choke is about 5 or 6 turns, roughly 4 inches diameter, some cable ties, and you've made a choke to stop any RF coming back down there. And then you would do that at this end. Because bearing in mind the other part of the design of these, they don't need any sort of counterpoise. So that would stop any stray RF coming down there. I've never bothered. I've never had a problem. But if you want to do it, it won't cause any issues to do something like that and just cable tie it up. You take any experience on it? What do you think of putting a choke on VHF, UHF aerials? HF I find yes, because you like to get RF back in the shaft if you don't.
Can't see it do any harm to do it, to be honest.
No. You're just losing a few feet,
Just want a few turns up.
a few turns up and just, yeah.
But if your match is perfect, then what reflected energy are you going to get?
Well, exactly. Yeah, very little.
Yeah, it may match perfectly, but if you've got the length of coax on it and it's not matched perfectly, if you change the length of coax, it will go off tune.
Yeah.
And that's a way of checking to see whether it is matched perfectly, is to change the length of coax and see if it makes any difference. If it does, then the coax is part of the tune circuit and you don't want that.
So doing that would probably stop them. Yeah. I've never bothered, but it's throw that out actually.
Yeah.
Use of it, yeah. And this is all cheap coax on this as well.
Yeah, it's a bit of
RG58, yeah. But it make a choke out of RG58, and then if you want to 213 feeding into it, that's something similar that size. Oh, no more questions?
No,
I don't think so, but I think we owe you a round
Did-
of applause. Thank you very much.
Thank you.
And I suppose we don't pack up too quickly. We've
No,
got
yeah.
a few examples we can peruse a bit more.
Absolutely.
So great, fantastic, thank you very much.
If anyone wants to have a look at that, I'm gonna send that.
Well, I didn't do much.
I'm gonna send that the PDF of that to Matt. It's got some quite interesting stuff in there.